I'm delighted to be here today, and it's fabulous to see such a large audience and many faces I know well and some new faces. And first thing I'd say is usually when I'm giving presentations, they're very technical. They're looking at building physics, looking at hydrothermal modelling and all these subjects. And I'm delighted to say I'm not going to refer to hydrothermal modelling at all. And I'm not going to go into relative humidities and complex Wi-Fi calculations for a change. So this is a relief. Instead, I'm going to show some beautiful pictures. Hopefully you'll agree with some experiences we've had in the UK over the years. And when I sat down at Penny, I suppose it was late last year, we were thinking about what masterclass we'd have and organise and what is very relevant in the UK at the moment. And a big area we saw of huge growth was the CLT area. Even though we don't actually supply CLT, and we've worked over the years with Will and many other speakers here over the years, and we've seen huge growth in CLT, and it's something I'm really excited about because I'm very passionate about wood, ecology and sustainability. So we thought it was a perfect subject matter to cover. My presentation will cover CLT and basically our experiences in the UK with CLT, along with our partners from Proclima and Gutex and HECO. But just to give a brief background on our company, we're based in Carlisle, as Penny was saying earlier on, centre of the universe. We've plenty of banter between our Irish office and the UK office. And here's some of the key team members Penny mentioned earlier on. As a company, we focus on supplying a lot of technical support. That's key for us, because from an early stage we realised that it's one thing supplying a high quality material to a builder or to a specifier on specification, but what's key is education and learning about the correct specification and executing the details on site. So what's crucial is not only learning about a material, but how to work with a material. And we supply a lot of site support and U-value calculations, and we have a training centre in Ireland as well as in Carlisle. It's expanding, and we run regional events as well. So in terms of my presentation, it'll be short and sweet, and Penny has threatened to hit me with a ½ metre HECO screw, but luckily I stole it from her, so I can speak all day, but don't worry, I won't do that, Penny. I'm going to go through the basic principles about CLT. I'm going to speak about airtightness and its relationship with CLT, but I'm very happy to say Ludo Helms from Proclima is going to give a very good presentation about that in much more depth, about how to attain airtightness with CLT in its various forms. And then I'll just give a brief introduction to insulation with CLT, but Mr. Ryan Bloom from Gutex will go into this in much more detail later on. And then I'll go through our experiences with a brief synopsis of 6 example projects with CLT which we've worked with in the UK. I suppose before I move on, I'm sure I'm speaking to people who are very familiar with CLT already, but I just thought it would be no harm in recapping on what CLT is, just in case any of you aren't fully familiar with the principle. CLT refers to cross-laminated timber construction. It's been in use for over 2 decades. It's made from several layers of timber, typically layered crosswise, in more or less massive sheets of plywood in a way. And cross-lamination, this provides dimensional stability and strength and rigidity. It's a very viable alternative to masonry and steel, and it's also used in many groundbreaking projects throughout the world, including the UK. But as we said, we have guests here and from the CLT industry, and they can go through it in much more detail with you. I have a video here which will just provide a brief synopsis and background about CLT, about the potential of CLT, and some of the more insight into its use internationally. And I'll just run this video it's about 3 or 4 minutes.
Over the past 5 years, the use of CLT in construction has risen dramatically. The material is now being used to construct impressive and sustainable homes, offices, schools and towers. Often referred to as super plywood, the material is constructed in a controlled factory environment from sustainably sourced timber. CLT is manufactured from spruce, although Scots pine, larch and Douglas fir can also be used. Once at the factory, the timber is planed and then kiln dried to reduce moisture content. The conditioned timber is then stacked into layers known as lamellas on top of one another. Each layer is placed at a 90-degree angle to the one beneath. These layers are then glued using a non-toxic adhesive and hydraulically pressed together to create the high-strength structural panels. Individual panels can in theory be any size. However, their width is limited by the size of the manufacturing machinery, which is usually around 11 feet or 3.5 metres wide. The length of the panel is only dictated by how it will be transported to site. While 45 feet or 13.5 metre lengths are typical for practical purposes, panels of up to 75 feet or 22 metres have been produced. Using state-of-the-art computer numerically controlled or CNC joinery machines, almost any shape of panel can be produced, meaning that door and window openings can be pre-cut in the factory. These off-site manufactured panels are then ready to be delivered to site. Fabrication is currently limited to only a handful of factories in mainly alpine countries, such as Stora Enso's in Austria. While this may require the panels to be transported to site by road, the embodied energy added to the project is far outweighed by the carbon savings. Proponents of CLT claim that producing timber building components consumes only 50% of the energy required to produce concrete, and mere 1% of that needed to produce steel. Prefabricated panels can be delivered to site as they're needed, making this construction method ideal for schemes with limited on-site storage capacity. They are then lifted into place using pre-installed lifting straps and rapidly assembled, greatly reducing construction time and therefore cost. As the timber used is kiln dried, CLT should not shrink or warp when on site. However, like most timber elements, CLT must be placed above the damp-proof level and will need protection when used on the external facade. CLT construction can also reduce the self-weight of a structure compared to concrete, potentially reducing groundwork costs. The construction process is also cleaner than traditional methods, with greatly reduced levels of dust. It is also quieter, a distinct advantage for projects built in urban areas. While there are numerous benefits to CLT, some people are fearful of living or working in timber buildings. Some believe these structures have an inherent fire risk, particularly when rising to 10, 20 or 30 stories tall. Unlike unprotected steel, CLT can remain structurally stable when subjected to high temperatures. When exposed to fire, the outer layer of timber chars and forms a layer around the structural core, which can retain its low bear capacity. CLT's inherent fire resistance allows it to comply with fire resistance classes, withstanding blazes for between 30 and 120 minutes, depending on its engineering and formation. CLT uptake and use was initially driven by the material's sustainable credentials. However, in recent times, a resurgent construction market that is placing pressure on traditional materials, along with increased awareness, has bolstered adoption. While early CLT buildings were predominantly small, low-rise structures, the material is increasingly being considered for taller schemes. Since architect Walt Thistleson built the first timber skyscraper, or plyscraper, in 2009, tall timber buildings have been planned around the world. In the past 5 years, towers of 30 metres, constructed from CLT, have risen in Australia, America and Europe. If you enjoyed this video and would like to get more from the definitive video channel for construction, subscribe to V1M.
So that just gives a good brief background on CLT and the principle. And to date, and this is the tallest CLT building being built at the moment in Vancouver. It's an 18-storey student accommodation being built with CLT. So you see the potential with CLT is quite significant. And I'm travelling to Vancouver at the end of next month, and hopefully I'll get to visit the site to see it. At the end of this month, actually. In terms of CLT and its application, the basic principle would be that the CLT would be erected, then it would be bolted together with Pico screws, or you can use dovetail connectors like Sherpa connectors. I think there are some samples outside with Aptus. Following that, the windows can be fitted, and then it is an option to just tape the joints in the CLT without applying a membrane. But another option is to apply a membrane on the outside of the CLT to give additional airtightness. to ensure you're meeting your airtightness requirements. So CLTs are quite airtight, but as Luder will show in more detail later on, they can have some areas of leakages at the joints of the CLT or between the plies if you're chasing the inside for sockets and so on. And to attain passive house levels of performance, it's better to wrap the CLT in a suitable membrane. This is one of ProClimate's membrane called DA. It's weather resistant, but it's also airtight and gives a degree of vapor control as well. And that's wrapped around the CLT in this case, and then it's taped at the joints with a tape called Tescon Vana. So if the membrane wasn't used, it would be simply a matter of using a high performance tape on the butt joint of the CLT, such as a Tescon Vana tape you'll see later on. Following that, the insulation is fitted. Here we see a single ply of Gutex multi-therm, for example. You can see this on the displays outside and in here as well. And this is initially fitted with some temporary screws, and then the battens are fitted on the outside, followed by the external cladding, which is a timber clad or cement board or whatever that may be. You'll notice with the Gutex boards, they're tone and grooved interlocking and they're watertight. The external Gutex boards are impregnated, so they're inherently very water resistant. The weak point would be at the butt joint of the board, wherever it corners or around windows. So at butt joints, it's important to prime the surface and then to use a suitable high performance tape, such as the Tescon Vana we see here. Of course, you can apply a Breda membrane on the outside of the wood fibre board for additional robustness and belt and braces. Or perhaps if you had an open jointed cladding and you wish to visually see a black finish between the open joint, you can use a membrane for that application. And ProClima do manufacture one called Solitex Fronta Quattro, which is a UV stable membrane, black in colour, so that when you have the open joint, you're not going to get degradation due to UV light. In terms of projects, this is one of the first projects we've worked on involving CLT. The very first project was with Urban Architecture. I'm delighted to see Steve here from Urban Architecture, a project in Flinwell. But this project, the Woodland Trust headquarters in Grantham, we worked on with Will. It was the first CLT project we worked with Will on. And it's a BREEAM excellent building. The walls utilised approximately 282 millimetres of Gutex in some locations. It's the first time I learned the term the bookend wall, and it stuck with me since, because that's where the thickest piece of Gutex was used. Yeah. It was generally 182 millimetres, but there was the bookend wall that went up to 282 millimetres. So technically we had to come up with details to address the increased thickness and the fixation onto that point. So it stuck with me. The building is very impressive. It has achieved a U value of 0.11, and it used a lot of the tapes and seals I referred to earlier on. Here we see it in actual application, where a combination of 3 Gutex boards were used. A board called Thermosafe Homogen, which is a relatively soft wood fibre board, but very compressive resistant, and it helps you build up your bulk depth of insulation. And then that's covered by one of the impregnated Gutex boards, which Reiner will describe later on, called Gutex Ultratherm. And in this case, no membrane was used on the outside of the Gutex, but we can see the ProClimate tapes, and you can just see the slight difference in colour. That's the primer on the substrate before the tape is applied. So it's very important to prime it first. If you don't prime, the tape can come away very easily. So that's very important. And we had a conference recently with some building control officers, and that's one thing they picked up on very much, not just with CLT, but with building in general, with concrete construction or any building. On site, a lot of people fail to prime a substrate before bonding to it. And on dusty or gritty surfaces, it's important to prepare the surface right before bonding. This building didn't use any membrane on the outside. It was timber batten on the outside and then an open jointed timber cladding wall. And here's another project. This is the Steiner School in Frew by Phelan Clegg Bradley, and it used a very simple principle. It used one layer of Gutex, 160mm multi-therm, and then a batten, and then timber clad open jointed and closed jointed. But this project also used a membrane on the outside because of that open jointed facade. The architect on the project wanted to get a visual aesthetic that you have that black appearance as you look through the open joint. Here's one of Will's early sketches, which I really, really like. You can do these wonderful CAD drawings and SketchUp on your computer, but I think these are really good. And just what I really like about this image is it just really transfers and translates the simplicity of the principle, where you have your CLT, you've got your single ply of Gutex multi-term, then you've got your UV resistant membrane here, the batten, and then the timber cladding. And then a very long screw to fix it all into position. And here it is on site with the initial temporary screws before the battens went on. This project is the Bitsu headquarters, and Bitsu manufacture bespoke furniture in Leamington Spa. This is on site at the moment. It's a 120mm cross laminated timber wall with 160mm, again, Gutex multi-term in one single ply. Here we see it fastened to the wall temporarily before the battens are applied. And the U value attained on this was 0.19 with 160mm of the multi-term on the outside. We had a 65mm thick batten followed by an external open joint cladding system. Crucial details in this project were ensuring that the connections to the adjoining building elements were made watertight. So at the building phase, we can see here some foam glass was used close to the foundation to address thermal bridging, and the CLT was glued to the outside of this brick here. So you're going to get a nice flashing detail there. And the butyl tape here, it's called X2C cores, and the contractor found it very fast to work with, and it's weldable. So it just took in the deviation and contours very easily. But again, the reason we show the slide is because look, if you see the surface preparation here, this substrate here proved to be quite gritty. Even the guys on site went with one of the air blowers that you use to blow the leaves to try and clean the dust from the surface and brush it, but still there was a little bit of grit there. So they applied the primer here, it's called Tescon RP primer, and then the X2C cores bonded very reliably to that substrate. In this project, they just, for the CLT, they didn't use an exterior membrane on the CLT, they just taped the joints with a tape called Tescon Vana. So that was the airtightness layer, the CLT itself. So it wasn't aiming, as far as I'm aware, for passive house levels of performance. It hasn't been tested yet for airtightness either. And there you see it on site with the boards ready to be fitted. So on the outside of this, we'll have the solid Frontal Quattro membrane installed with the open jointed cladding for UV stability. This project is a private dwelling, and it'll be presented later on, by Tectonics Architects. And it's a very interesting project in that it's a certified passive house, but it used quite a considerable depth of Gutex on the outside. It used 320mm of Gutex, which required quite long screws, and that's why I brought this with me, the real reason, because it was these 1/2 meter long Eco screws were used. And at the time I ran through the screw calculations for fixings, and I got to speak with Paul from Eco. He's very helpful in their technical office, and just to double check, that is actually okay. Because as an engineer, I didn't doubt myself, but I just wanted to speak to another engineer and run through the calculations and to double check my calculations. So I can hand that around. So that's the Eco screw. So this project, it attained 0.29 air changes per hour at 50 Pascal, and for a passive house you must get less than 0.6 air changes per hour at 50 Pascal, so it came well within that requirement, and the U value on the wall was 0.1. Here we see the CLT with 3 layers of Gutex and 2 layers of Gutex Thermosafe Homogen, followed by a board called Gutex Ultratherm on the outside, a batten, and then a 1/2 meter screw going back to the CLT. That's one of the benefits with CLT when you're using such long screws, because an issue we often come across is on a timber frame. You're looking for your 400 or 600 center stud that may be 44mm wide, and trying to get through that depth of insulation and hit that stud, it can be chancy enough. So with a CLT, you've got a full uniform substrate, so you're never going to miss the point of connection, and there's no risk of splitting wood or timber. So it's really, really good. So in terms of the process with this project, we worked with Bernard Tulkins on a big issue was getting the material to site. The CLT was one thing, but then it was a very restricted site, so getting the material to the site and making sure that the people installing it were doing it correctly. And Bernard took on board some of our leading experts that we recommend for installing airtightness and installing Gutex, who installed it on this project, Roman Segura, and another fellow called Dave Broderick from Ireland. And I did the installation of the air barrier layer, the Proclima DA membrane, taped on overlaps with the Tescon tape. This is the Hego screws that were used, and I'm not going to speak much about that because Paul is going to go into that in much more detail later on, but I know myself working with the screws when I got training in Germany with Hego, it's incredible the difference if you have the wrong screw in terms of burnout of the motor on the drill, speed of application, and the number of screws you need. Depending on the screw you use, it's a big factor to take into account. All calculations for screws in this project were carried out in accordance with Euro Code 5. How is that going to still apply after Brexit? I don't know, but that's the standard we followed. And as I said, there were 8mm by 500mm screws. And in terms of the application, here we see the installers working with it. For installing the screws, we basically, as will be covered later on in much more detail, the principle is to install what's called a suction screw, which is a screw inserted at 90 degrees to the frame, followed by a screw called a shear screw to deal with the shear loading, especially when you've such a deep layer of insulation and you've the load of the cladding to bear in mind. So this screw is inserted at, you come down 30 degrees, and this is a handy template which you use just to get your initial impression. Insert the screw and then you work away to your angle. So that's fitted onto the batten to give you your angle, and then you fit it in. That's a Hego template. And that around. So that helps you guide to ensure you're inserting the screw at the right angle. And there we see the boards being fitted on that project. And then following that, the boards are made watertight. While I say the boards are inherently watertight at the tongue and groove joints, at the butt joints, that's where you may have a weak point, and that's where it's primed again and taped at the joint. So there's no membrane used externally on this project. And then you had the external cladding on the outside of that. Key points were the flashings around sills and door thresholds. These were very important. And then we see the beautiful inside of this project later on. Bernard will go through this in much more detail later on. That project was supplied by Urban CLT. This project here in Thorn Witness, by Thorn Witness Architects on the Isle of Mull, is another CLT project. It's a social housing project, and we see it employed a lot of the wood fibre board. The wind tightness layer on the outside of the roof, this is called Solitex Plus. So all joints were taped on the outside. In the case of this roof, it's a very exposed site, for weather tightness was very important. On this particular project, they actually just taped directly to the CLT and taped overlaps and joints in the CLT with the Tescon tape for airtightness. Again, the windows were sealed back to the CLT with the butyl tape, the X2 sealant in course. It achieved a Q50 of 0.4 cubic meters per square meter, so very impressive level of airtightness on that particular project. Finally, this is a CLT Passive House school here in London by Van Heinigen. I've been practicing that this morning, and Howard Architects. So we see on this project, they again employed an exterior airtightness layer on the outside of the CLT because they're aiming for Passive House certification on this project, and they want to ensure they're actually going to hit their target. And then on the inside, we see the exposed CLT in all its beauty, and key junctions and details around window openings were detailed with the proprietary tapes and seals. I think I'm just about on time, Penny, so I'm coming to my summary. In terms of CLT and using wood fibre insulation as well, they're very compatible materials. When you're working with CLT and wood fibre insulation, it's just a perfect match, and it optimises the overall breathability of the structure. It offers outstanding thermal performance, and as you see, wood fibre has been used regularly on these projects now to achieve the ultimate in terms of efficiency, in terms of passive house levels of performance. It's an off-site construction, very much reduces the risk of unforeseen issues, and its faster erection of the building reduces costs. It's a carbon sequestering material, much more ecological and more cost effective as well. To finish up, I'm just going to use this slide here because there's a friend of mine, he works in the Canadian Wood Council, and this is a question he's often asked, why should we be building with wood? And the answer he gives is as follows. When someone invents a material that's renewable, reusable, organic, biodegradable, whose production cleans the air and water, sequesters carbon, creates oxygen, provides a habitat for us and other species, gives us a material that is strong, light, diverse, versatile, beautiful, ubiquitous, and inexpensive, then I'll invest in it. But until then, I'll use wood. If not wood, then what? And that's what Peter says. And I think it's a very good summary of why we use wood and why we should use more wood in construction.